This lecture, we're going to cover section P6, rational expressions, and this is the last section in the prerequisite chapter. So what's a rational expression? I think of it as a fraction, really. It's just the quotient of two polynomials. But we have to be careful. So when we're examining rational expressions, since it is a quotient or a fraction, we have to think about the domain. Now remember, the domain is the list of all possible x values for which the expression would be defined. Now, whenever we have a rational expression or a fraction, we have to think, okay, well, the denominator of a fraction can't be equal to 0, right? We can't divide by 0. So then we have to think about, all right, what must we exclude from that rational expressions domain, right, that make the denominator equal to 0? So for example, let me go to the whiteboard for a second. Suppose my rational expression was equal to 1 over x, right? That's a simple rational expression. It's a quotient or a division, right? It's a fraction. We have to think about the denominator, right? I'm taking 1 and I'm dividing it by x. But what's going to make this fraction or quotient undefined? Well, if I divide by 0, right? Look what happens when we divide by 0. So let me share my calculator. So for example, what if I had 1 and I tried dividing it by 0? So if we did 1 divided by 0, my calculator says that's an error. We can't divide by 0. So we get something that's undefined. We can't divide by 0, in other words. So my question for you guys to think about is, all right, if 1 over x is my rational expression, what values of x would make this expression undefined, right? Well, anything that would make the denominator equal to 0. And my denominator is x, right? So set x equal to 0, and that's what x would have to be, right? 0. Because if x was 0, I'd have 1 divided by 0, and we would have an expression that's undefined. So my domain is all values of x such that x is not allowed to be equal to 0. So the way we write that is we use set builder notation. So we say, okay, here's my set, right? We use the brackets, the little squiggly ones, and we say, all right, x could be anything such that, so that vertical line implies such that x is not allowed to be 0, but it could be anything else. So this says, okay, x could be anything such that x is not equal to 0, but it could be everything else. So let me give you another example. What if my function was, or my rational expression was 4 over x plus 3? When would this expression be undefined? So in other words, what would x have to be such that the denominator would be equal to 0, right? Because I can't divide by 0. I can't take 4 and divide by 0. So let's set the denominator equal to 0. So take the denominator, x plus 3, set it equal to 0. When would that happen? For what value of x? So let's solve for x. So if I subtract 3 from both sides, I'm going to get x is equal to -3. Which makes sense, right? Because 4 over, let's replace x with -3, right? -3 plus 3 would be equal to 4 over 0. And this is undefined. So x is not allowed to be -3, right? Because if it was, I'd have 4 divided by 0, and that's not a real number. We can't define that. So my domain would be all values of x such that x is not equal to -3. So the number that we have to exclude from the domain is -3, in other words. And this is important because when we solve rational equations, we might get an answer that we're going to have to reject because it's not part of the domain. So that's why this is important. So let's go back to the worksheet. And example 24 says, okay, find all numbers that must be excluded from the domain for the following rational expression. So let's look at the expression in A. So we have 7x divided by x minus 4. So when would the denominator be equal to 0? That's what we have to think about, right? Because whatever that value of x is, we need to exclude it from the domain. So set x minus 4 equal to 0 and solve. So if I add 4 to both sides, I'm going to get x equals 4. And look what happens when I plug in 4 into the denominator. 4, right? If I replace it for x, 4 minus 4 would be 0. And then I'd be dividing 7x by 0, and I can't divide by 0, right? So we need to exclude x equals 4 from the domain. Let's look at B. So my rational expression is 5 over x squared minus 5x minus 14. Again, we need to think about what x values would make my denominator equal to 0. So let's set the denominator equal to 0 and figure out, okay, when would that happen? For what values of x? So we're going to set x squared minus 5x minus 14 equal to 0. Now, this is a quadratic. So remember, the way we solve quadratic equations is we factor and set each factor equal to 0. So let's factor x squared minus 5x minus 14. So what two numbers multiply to -14 but add to -5? So that's going to be a -7 and a +2. The reason we solve this way is the following. So let me go to the whiteboard for a minute. If I have two factors that are equal to 0, so let's say I have A times B is equal to 0. I have a product here. What's the only way I can multiply A and a B and get 0? One of them has to be equal to 0, right? Either A is equal to 0 or B is equal to 0. That's the only way that a product could be equal to 0, right? One of the factors has to be equal to 0. So that's why I'm going to set each one of these factors equal to 0, right? So I want to know, okay, when would x minus 7 be equal to 0? And when would x plus 2 be equal to 0? For what values of x, right? So we're going to solve each of them. So look, here I'm going to add 7. So I'm going to get x equals 7. And when I solve x plus 2 equals 0, I'm going to subtract 2 from both sides, and I'm going to get x is -2. So if x was equal to 7 and if x was equal to -2, when I go to plug those into the denominator of my fraction, I'm going to get 0, which is no good, right? We can't divide by 0. So we need to exclude x equals 7 and x equals -2 from the domain. right? Because that's what we're trying to figure out. What should be excluded from the domain? So let's do one more. Let's look at C. So I have 2 divided by x squared minus 16. So let's think about this. When would the denominator be equal to 0? So let's set x squared minus 16 equal to 0. We want to solve for x, just like we did in B and A, but we have a quadratic, so we can factor it again. So look, x squared minus 16 is the difference of squares. So this is x plus 4 times x minus 4, right? That gives me x squared minus 16. Set that equal to 0. Now set each factor equal to 0. So I'm going to have x plus 4 equals 0 and x minus 4 equals 0. And when I solve, I'm going to get x equals negative 4 and x equals positive 4. So look, when x is negative 4, and I plug that in for x for the x squared, right? I'm going to get 16. And 16 minus 16 would be 0, and I'd have 2 divided by 0. Same goes for 4. If I plug in 4 for x, 4 squared is 16. 16 minus 16 is 0, and I would have 2 divided by 0. So for C, we need to exclude x equals negative 4 and x equals positive 4 from the domain. So now we're going to take a look at how to simplify a rational expression. Now, how do we know when a fraction is simplified? Well, that would mean that the numerator and denominator have no common factors other than 1 or negative 1. So for example, I'm going to go to the whiteboard again. So for example, let's say I have the fraction 2/3. That is in simplest form. I can't reduce it any further, right? Because a 2 and a 3 only have a common factor of 1. So this is simplified. But what if I had 2/4? I could reduce that or simplify that fraction further, right? I could simplify by a factor of 2. 2 goes into itself once and into 4 twice. So this is equal to 1/2. So 2/4 is the same thing as 1/2. But 1/2 is the simplified form, right? Let's do one more. So what if I had 18 over 24? I can simplify that expression, that fraction, that quotient. 18 and 24 have a common factor of 6, right? 6 goes into 18 3 times, and 6 goes into 24 4 times. So I could rewrite 18 over 24 as 3/4. That's all we're doing when we look at these rational expressions and we want to see if they're simplified. We're going to make sure that the numerator and the denominator have no common factors other than 1 or negative 1. And the way we're going to do that when we have these rational expressions that contain polynomials in the numerator and the denominator, first we're going to factor the numerator and the denominator completely, and then we're going to divide the numerator and the denominator by any common factors, and that's going to reduce the fraction or the rational expression. So let's look at this example in 25a. We have 3x minus 9 divided by x squared minus 6x plus 9. We want to simplify it. So we need to look for common factors, but the only way to do that is to factor each polynomial in the numerator and the denominator. So let's factor 3x minus 9. I could factor out a 3. And then my other factor is going to be x minus 3, right? Now let's factor the denominator. I have a trinomial in the form x squared plus bx plus c. So I'm going to use the factoring method that we used in the previous lecture, the previous video. Now tell me what two numbers multiply to positive 9 but add up to negative 6. So that's going to be a minus 3 and a minus 3, right? Negative 3 times negative 3, positive 9, but negative 3 plus negative 3 is my negative 6. Now that we're in factored form, I can look at this and say, okay, in the numerator, I have an x minus 3. And in the denominator, I also have an x minus 3, right? X minus 3 over x minus 3 reduces to 1. That's the only common factor that I have in the numerator and the denominator. So now all that's left is the 3 in the numerator and the x minus 3 in the denominator. So my simplified answer would be 3 over x minus 3. So let's look at B. We want to do the same thing. We want to simplify the rational expression, but let's factor the numerator and the denominator if possible. So my numerator is x squared minus 1. And that's a difference of two squares, right? X squared minus 1 squared. So this is going to be x plus 1 times x minus 1. And then I'm going to divide that by the factored form of this trinomial, x squared plus 2x plus 1. And I can factor this trinomial by thinking of what two numbers multiply to 1 but are going to add up to 2. And that's going to be a positive 1 and a positive 1. And now I could reduce by my common factor, right? So we see that I have an x plus 1 over an x plus 1. That reduces to 1. And what's left, right? So we have an x minus 1 in the numerator and an x plus 1 in the denominator. So that rational expression simplifies to x minus 1 times x plus 1. Let's do one more. So for C, I have a trinomial in both the numerator and denominator. So let's factor the numerator first. X squared plus 7x minus 18. What two numbers multiply to negative 18 but add to 7? I'm thinking a 9-2 combo, right? It's going to be a positive 9 and a negative 2. And then let's factor the trinomial in the denominator. So we have to think, okay, what two numbers multiply to 2 but are going to add up to negative 3? And that's going to be a negative 2 and a negative 1. Now that we're in factored form, I see that I have a common factor of x minus 2 in the numerator and the denominator. So I'm going to reduce that to 1. And my answer in simplest form is going to be x plus 9 divided by x minus 1. So that's how we simplify rational expressions. We could also perform multiplication, division, adding, and subtracting on our rational expression. So the first thing that we're going to do is multiply rational expressions. So when multiplying rational expressions, again, it makes it easier to factor first, because once we factor the numerators and denominators completely, then we can divide out by common factors. And whatever's left, we could take the product. So we're going to follow those 3 steps. So let's look at example 26. I want to multiply x minus 2 over 3x plus 9 by 2x plus 6 over 2x minus 4. So rather than trying to multiply the numerators and multiply the denominators, let's factor first, because I think it's easier to factor and divide, right? Or reduce by common factors and then multiply rather than doing it the other way around. So look, let's rewrite. So x minus 2 can't be factored. So I'm going to leave that as x minus 2. But I can factor 3x plus 9. I'm going to factor out a 3. So that's going to leave me with 3 times x plus 3. Times. Now let's factor 2x plus 6. So I'm going to factor out a 2. And then I'm going to have times x plus 3. And factor the denominator 2x minus 4. So I'm going to factor out a 2. And then my other factor is going to be x minus 2. So that was my first step. Factor the numerators and the denominators. Now what I want to do is divide the numerators and denominators by any common factors. So you see in the numerator, so it's 1 to 1. For every one factor you see in the numerator, you could reduce that or cancel it or divide it by that same factor in the denominator. So look, here's an x minus 2 in the numerator. Here's an x minus 2 in the denominator. I also have an x plus 3 in the numerator and x plus 3 in the denominator. So I could divide those out and I get 1. So now step 3 is just multiply the remaining factors. And look what we have. All I have in the numerator is just a 2 left. 2 times 1, which is 2. And in the denominator, I have a 3 times a 2, which is going to be 6. And I could reduce this even further, right? 2 goes into itself once and into 6 3 times. So that's going to simplify to 1/3. Let's do one more example. So B, we have x plus 3 over x squared minus 4 times x squared minus x minus 6 divided by x squared plus 6x plus 9. So let's do the same thing that we did in part A. Let's factor any numerator and denominator that we can. So x plus 3 can't be factored any further, so I'm going to leave that as x plus 3. But my denominator, x squared minus 4, that's a difference of 2 squares. That's going to be x plus 2 times x minus 2. Then my other numerator, x squared minus x minus 6, I'm going to think, okay, what 2 numbers can I multiply to get -6, but it's going to add to -1, the middle term, right? So that's going to be a -3. No, I'm sorry. It's not going to be a -3 and a 2. We're going to have a -6 and a +1, right? -6 times 1 is -6, and -6 plus 1 is a -5. No, that's not what I'm going for. I'm like having a moment here. It's going to be 3 times 2, right? So we're going to have -3 and a +2. There we go. -3 times 2 is -6. -3 plus 2 is a -1. That was a close one. All right. Now we have x squared plus 6x plus 9. So let's factor that. So what 2 numbers multiply to 9 and add to 6? And that's going to be a +3 and a +3, right? 3 times 3 is 9. 3 plus 3 is 6. So now we're ready to reduce by common factors. So in the numerator, I have an x plus 3, and in the denominator, I have an x plus 3. And then I also see I have an x plus 2 in the numerator and an x plus 2 in the denominator. And that's about it in terms of my common factors. So what do we got left, right? So in the numerator, all I have is x minus 3. And then in the denominator, I have an x minus 2. And remember, we're multiplying. So that's going to be x minus 2 times x plus 3. So remember, when we multiply fractions, we multiply across the numerators, we multiply across the denominators, and we end up with a single expression. So we're going to have x minus 3 divided by x minus 2 times x plus 3. So now let's talk about division of rational expressions. So we just did multiplication, and now we want to divide rational expressions. And I just want to remind you of something. So I'm just going to go over to the whiteboard for a minute. When we divide fractions, right, how does that work? So we just did multiplication of fractions, and I feel like that's people usually remember that, right? So if I have A divided by B times C divided by D, right? Multiplication, you multiply the numerators, so that's going to be A times C, and then we multiply the denominators. So that's in the denominator, we're going to get B times D. So AC over BD. That's what we were just doing. But I feel like sometimes it takes people a minute to remember how to divide fractions, right? So what if I had A over B and then divided by C over D? So how do we divide fractions? So remember, with division of fractions, we multiply the first fraction by the reciprocal of the second fraction. And remember, the reciprocal is when we interchange the numerator and the denominator. So that's going to become D over C. And that's going to give me AD divided by BC. So whenever we divide fractions, we multiply by the reciprocal. And that's what we're going to do for this next set of examples. So let's look at number 27A. I usually just make the change first so I don't forget, so I don't treat it as the original as multiplication. So why don't we do this first? So this is the same thing. Let's just rewrite this as x squared minus 4 over x. Change division to multiplication, so times, but then I have to take the reciprocal of the second fraction. So that's going to be x minus 2 divided by x plus 2. So you see how I inverted the numerator and the denominator, right? And we're going to multiply. But that just brings us to what we were doing in example 26, right? We were multiplying rational expressions. And how did we do this? First, we factored, and then we simplified. We're going to do the same thing here. This is really just multiplication, right? So let's factor each numerator and denominator. So x squared minus 4 is going to be x plus 2 times x minus 2 over x. And then we're going to multiply that by x minus 2 divided by x plus 2. And let's go through and reduce by any common factor. So I see I have an x plus 2 in the numerator and the denominator. And that's about it. I can't, you see how I have another x minus 2 and another x minus 2, but they're both in the numerator, right? So they don't reduce like that. That one has to be in the numerator, one in the denominator. So what I'm going to have here is x minus 2 times x minus 2 divided by x. And we could write that as x minus 2 squared, right? And then divided by x. So let's do one more. B. So I don't forget, I'm gonna first rewrite this as multiplication. So we have x squared minus 2x plus 1 over x to the third plus x. And then I'm going to change division to multiplication and take the reciprocal of the second fraction. So that's going to be 3x squared plus 3 divided by x squared plus x minus 2. And now let's factor. So let's factor x squared minus 2x plus 1. So two numbers that multiply to positive 1 and add to negative 2 are going to be a negative 1 and a negative 1. Now, if we factor the denominator, x to the third plus x, I could factor out an x. And I'm going to be left with x squared plus 1. Times, now let's factor 3x squared plus 3. We could factor out a 3. And we're going to be left with x squared plus 1. Over, now let's factor x squared plus x minus 2. So two numbers that multiply to negative 2 and add to positive 1. So that's going to be a positive 2 and a negative 1, because 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. So now that we're factored, I'm ready to go through and reduce by common factors, right? So you see how I have an x minus 1 in the numerator, x minus 1 in the denominator. And I also have an x squared plus 1 in the numerator, x squared plus 1 in the denominator. So now what product are we left with in the numerator, right? All I have is an x minus 1 times a 3. So that's 3 times x minus 1 over, in the denominator, all I have is x times x plus 2. So that would be my simplified answer. 3 times x minus 1 divided by x times x plus 2. So that's how we divide rational expressions.